All right, everybody, welcome back for another deep dive. Today we're going to try to decipher some pretty intense stuff.
hmm
It's ABGs, arterial blood gases.
Ooh, yeah, those can be tricky.
Yeah, they can be a little head scratchy, but I think they're really interesting because they're such a good window into what's going on in your body, especially with
Oh.
your lungs and your kidneys, how well they're working.
Yeah, it's a direct measurement of like how well your body's doing right now. It tells you if your organs are functioning properly, if something's out of whack.
Exactly. It's like a snapshot in time.
Yeah.
And to understand them, you got to understand the balance of oxygen, carbon dioxide, and acid-base levels in your blood.
It is a balancing act, like a delicate dance between different systems.
And we're going to try to break down that dance, starting with the key players in this whole ABG situation.
All right, let's do it. So we've got our 3 stars. pH, PaCO2, and HCO3. They're the ones giving us all the clues.
Okay, so pH, that's probably what people are most familiar with. It's all about how acidic or alkaline something is, right?
Right. Think of it like a scale. Yeah, 0 to 14. 7 is neutral, like pure water. Anything lower than 7 is getting more acidic, and higher than 7 is more alkaline or basic.
So our blood needs to stay within a very specific pH range to function properly.
Absolutely. It's a pretty tight range, too, around 7.35 to 7.45. Even a small shift outside that range can cause some serious problems.
Okay, so pH is all about balance.
Mhm.
But how do the other two players, PaCO2 and HCO3, factor into this? What do those even stand for?
Right. PaCO2, that's the partial pressure of carbon dioxide in your blood. It basically tells us how well your lungs are doing their job of getting rid of CO2.
So if your PaCO2 is high,
That means your lungs aren't removing CO2 efficiently.
got it. And HCO3, that's bicarbonate, if I remember correctly, is our body's natural antacid, right?
You got it. Bicarbonate is key for neutralizing acids in the blood and keeping that pH balanced.
And which organ is the master of bicarbonate?
The kidneys, they're like the bicarbonate control center. They filter it, reabsorb it, and even generate more if needed.
Okay, so we've got the lungs controlling CO2 and the kidneys managing bicarbonate. It's like a tag team effort to keep our pH in check.
It's a beautiful system, actually. They're constantly working together, even compensating for each other when things get out of balance.
So how does that compensation thing work? Let's say someone has a problem with their lungs. They're not getting rid of enough CO2.
Okay, so that means they're heading towards respiratory acidosis, right? Too much CO2 makes the blood more acidic.
Right, the pH starts to drop. But the kidneys can sense that and jump in to help.
Exactly. They'll start holding on to more bicarbonate, trying to neutralize that extra acid and bring the pH back up.
So even though the lungs are the root of the problem, the kidneys are working overtime to compensate.
Yep. And the reverse is true, too. If someone is hyperventilating, blowing off too much CO2, their pH goes up. That's respiratory alkalosis.
Makes sense. So then the kidneys try to compensate by getting rid of some bicarbonate.
Exactly. They'll excrete more bicarbonate in the urine to try to bring that pH back down to normal.
So we've got the lungs and kidneys working together to keep the pH balanced. But of course, things don't always go perfectly. And that's where those acid-base disorders come in, right?
Yep. Those are the times when the compensation mechanisms can't keep up and the pH really starts to shift out of that healthy range.
So we talked about respiratory acidosis and alkalosis, which are problems originating from the lungs. But what about the metabolic disorders? Metabolic acidosis and alkalosis. What's going on there?
So in metabolic acidosis, the problem isn't with CO2, it's with bicarbonate. Something is causing bicarbonate levels to drop, which means the body is losing its ability to neutralize acid.
And that could be from...
Lots of things. Kidney failure is a big one. If the kidneys are damaged, they can't hold on to bicarbonate as well. Diabetic ketoacidosis is another. The body starts producing excess acids, overwhelming the bicarbonate buffer system.
And metabolic alkalosis is the flip side of that, right? Too much bicarbonate, making the blood too alkaline.
Exactly. This can happen from excessive vomiting, where you're losing stomach acid, or from overuse of diuretics, which can mess with the kidney's electrolyte balance and lead to bicarbonate retention.
So we've got these four main disorders: respiratory acidosis, respiratory alkalosis, metabolic acidosis, and metabolic alkalosis. I'm guessing this is where interpreting those ABG results gets really tricky.
Yeah, it takes practice, but if you break it down systematically, it's not as bad as it seems.
So what are the steps for decoding these ABGs? Where do you even begin?
First, look at the pH. That tells you the overall picture. Is the blood too acidic, too alkaline, or just right?
Okay, then what?
Then you look at the PaCO2 and the HCO3. Are they normal, high, or low?
And by comparing those values, you can figure out if it's a respiratory or a metabolic problem.
Right. High PeCO2 means respiratory acidosis. Low PeCO2 means respiratory alkalosis.
And for metabolic issues, we look at the HCO3. Low bicarbonate means metabolic acidosis. High bicarbonate means metabolic alkalosis.
Exactly. And then the final piece is to look for compensation.
Right, to see if the other system is trying to balance things out.
Like in that example from the study, the patient with diabetic ketoacidosis.
Oh yeah, that one was interesting. They had low pH. Their blood was acidic and low bicarbonate, so classic metabolic acidosis. But their PeCO2 was also low, meaning their lungs were trying to compensate.
Exactly. They were breathing faster to blow off CO2 and counteract that metabolic acidosis.
It really is amazing how the body tries to maintain that balance.
It's a constant push and pull, a delicate dance between different systems all working together.
It makes you appreciate just how complex and incredible our bodies really are. So listeners, next time you hear about ABGs, hopefully it won't seem quite so mysterious.
Think of it as a fascinating glimpse into the body's inner workings, all thanks to those three little letters: pH, PeCO2, and HCO3.
And maybe, just maybe, it'll make you take a nice deep breath and appreciate the incredible balancing act happening inside you right now. Thanks for joining us for another deep dive.
Until next time.
See ya.
You've been listening to the Learning Podcast, a production of metaNESTA. Remember, learning is a journey. One step, one insight, one skill at a time. We'll see you next time. Keep learning, stay curious, and as always, be awesome.